Virtualization alone does not mean that we have a cloud computing environment. As an example, imagine that in your on-premises network environment, you have a couple of physical hosts. Maybe they're running VMware ESXi, maybe they're running Microsoft Hyper-V, but you're running some virtual machines in your environment. That in and of itself does not mean you have a private cloud. Private because it's on-premises. In order to have a cloud of any type, you need to meet all cloud computing characteristics, such as resource pooling, broad access, metered usage, self-provisioning, and so on. However, virtualization is required by cloud computing environments. So when we deploy cloud services, even if we don't seem to have access directly to an underlying virtual machine, there is an underlying virtual machine somewhere handling that web application or hosting that function that we are running in the cloud as a software developer. So there's virtualization in use in cloud computing environments. The thing to bear in mind as well is that operating system virtualization, so running Linux or Windows virtual machines, requires a hypervisor. A hypervisor is not a piece of hardware, technically. Hypervisor is a software solution. Now, a Type 1 hypervisor and a Type 2 hypervisor behave a little bit differently, and we'll go through the differences between those in a moment. We also have other variations of virtualization besides just operating system virtualization. For example, we can virtualize a single application. So the application might be streamed to a user device, and to the user, it's as if that app is installed locally, when really, it's not. The other thing to think about are application containers, which is of special interest to software developers. One of the reasons is because an application container houses only application components, not an entire operating system. And so when it comes to software development and testing, software developers love containers because they start up very quickly. They start up quickly because they rely on the underlying operating system on the host that's already running. They do not contain and therefore do not have to start an operating system, as is the case with a virtual machine, with operating system virtualization. Another aspect of virtualization is software-defined networking, or SDN. When a cloud tenant provisions network resources in the cloud, like a virtual network with an IP address range, that is handled by the software-defined networking, or SDN, gateway. So, as a tenant, we have a GUI interface or command line tools to make it easy to deploy virtual network settings, but the SDN gateway will grab those commands and use them to actually configure the underlying network equipment in the data center. Now, the great thing about SDN is it saves cloud tenants from having to have specialized knowledge of how to configure the underlying vendor network equipment, whether it's routers or switches. So we briefly discussed hypervisors. Let's go into a bit more detail. A Type 1 hypervisor is itself the operating system. It's not an app that you install into an OS. It is the OS. And it runs directly on physical hardware, so it's often called a bare metal hypervisor. Now, Type 1 hypervisors are designed to be hypervisors to allow access to hardware resources and control that access among many running virtual machine guests. So they're streamlined to support virtualization hosting. So examples of a Type 1 hypervisor would include VMware ESXi and Microsoft Hyper-V. Now, a Type 2 hypervisor is a little bit different because it is not the operating system itself. It's an app that runs within an existing operating system, whether that operating system is a variant of Windows or Linux or the Mac OS. So what this means then is the stability and performance of the operating system will affect running virtual machine guests. If we have a slow server running, let's say, a Linux Ubuntu operating system, and we are running virtual machines on top of that in a Type 2 hypervisor, well, because the OS is already slow, so will the virtual machines. So therefore, Type 2 hypervisors not designed to run mission-critical workloads. For this reason, you're better off choosing a Type 1 hypervisor if you want to run something that's mission-critical, where you require the utmost in performance and stability. So examples of a Type 2 hypervisor would include VMware Workstation, Oracle VirtualBox, that type of thing. Then there's the notion of dedicated virtual machine hosting. Essentially, this means you are renting the use of a physical server running a hypervisor in a data center. So it's used by a single cloud tenant running only their own virtual machines. Now, why would this be something we might be interested in? We might require for regulatory compliance or to meet security standards of some kind to not co-host virtual machines with other organizations or other government agencies. We might have to have our own physical host to run our own VMs. With virtualization and self-provisioning of that virtualization in the cloud made so easy, it can result in what's called VM sprawl. It's very quick and easy to provision virtual machines, whether using a template, whether using the Azure portal, the Azure CLI, or PowerShell commandlets. It doesn't take very long. Now, the problem is that over time, we might forget about virtual machines that were provisioned in the past that were important for some reason but are no longer relevant. And so, if those virtual machines are left running, then we are paying for them while they are running every minute. If the virtual machine is not running, we're still paying for any virtual hard disks attached to that virtual machine in terms of storage capacity. Not only that, it's more cloud resources to look at in Azure when we are doing our day-to-day management that we don't need to see. Now, there are many ways that we can deal with things like VM sprawl and even in general unused cloud resources besides virtual machines. The Microsoft Azure Advisor can provide recommendations such as resources that haven't been used for a long time, or we might build a customized script that would look for things like unused virtual machines that are forgotten about.